was the equation of velocity? Velocity was the derivative of our original equation, right? So velocity was what? 160 minus 32t. That was the equation of velocity. And what's acceleration again? That's the derivative of velocity. It's the second derivative of the original function, right? Well, I can go back and look at the original function and do it twice. Or no, I already had the derivative once. So my acceleration is just the derivative of whatever velocity is. So what's the derivative of 160? What's the derivative of negative 32t? So the acceleration will always be, what is this in feet per second? But it's acceleration, second squared. So it is either negative 32 feet per second squared, or you say it is falling downward, or acceleration is pulling downward at 32 feet per second squared. That should be its gravity. Does gravity ever change? There you go. When does the rock hit the ground? Which equation do you think we're going to use? Position, velocity, or acceleration? Position. Because where's the ground? Where's the ground? It's at 0, isn't it? So the position is 0. Starts there and it ends there, right? So what was our original equation? This was the original position equation. If it hits the ground is a height or a distance of 0. Okay? So I'm going to set that equal to 0 myself. Alright? This thing right here? Yes, this is 0. It looks like a D, maybe an O, but it's a 0. Yes. So, 0 equals 160t minus 16t squared. Oh my God, all my students in Algebra 2 and in pre-calc, I tell them you can't forget how to fact. For some reason, they just think, great, I got through that 2-week unit, I'm never going to have to know it again. What was the first thing I should do? I can move a t, I can move a 16t. Either way, you get the same answer. But for the sake of simplicity, it made sense. 0 equals, if I factor out a 16t, what's left? Not 1. 10 minus t. Now I just keep going. Solve, right? For each one. Let's do this. Another color. Feeling festive. So 16t equals 0, and 10 minus t equals 0. So what are both of those values going to end up being? Yeah, t equals 0, and t equals 10 seconds. So which one of these is when the rock hits the ground? 10 seconds. At 0 seconds, it started on the ground. Boom! Thing goes off, rock goes flying, comes back down, and hits the ground again, 10 seconds. What was the time, just out of curiosity, what was the time that we set the rock at its highest point? Yes. It was at 5 seconds. See the first thing we did? We figured out we used 5, and that's how we got 400 feet, because it was at time 5. When the velocity was 0, when it was changed from going up to down. So, doesn't that make sense? If the rock started here, big dynamite, thank you. I went to art school. Boom! Bang! Takes 10 seconds for the rock to probably be in a million pieces over here, I don't know. 10 seconds. Doesn't it make sense if this is a parabola? The high point was at 5 seconds? It does. It makes sense. Example, a particle moves along a line so that its position at any time is given by this position formula, S of t equals t squared minus 4t plus 3. S means meters, and t is seconds. Okay? Find the displacement of the particle during the first 2 seconds. Okay? They always say a particle may move along a straight line. Not always, but here's a little particle. It's more of an atom. Yeah, look at that. Oh, I'm on box. No, now I'm not. Okay, I'm going to pretend that I did 2 more loops there. Pretend it's a particle. And this thing moves. Oh my goodness. Half the particle moves this way. It goes here, and then it goes here, and this particle moves along the line. And it's represented by this term, by this equation right here. Okay? How do I figure out the displacement in the first 2 seconds? What do you guys think to do? Go ahead. Let's put 2 in for t. Brilliant start. So I'm going to say, well, what's the position 2 seconds from now? So that's, and I'm going to use this, right? 2 squared. Don't forget parentheses. If that number is negative, you have to square the negative as well. Minus 4 times 2 plus 3. What is that? That is 4 minus 8 plus 3. Negative 1. Why is negative 1 not the answer? In this instance. It's moving to the left 1 spot, but how come that's not the answer? What does displacement mean? To be moved from somewhere. It's, well, no. I need to figure out where it started. I know where it's at now, but where did it start? I'm assuming it doesn't have to start at 0. Where did it start at 5? The displacement's different if it went from 5 to negative 1 than if it went from 0 to negative 1. Yeah, so you figure out where it started by putting in at time 0, where was it? So what about at time 0? And these are always easy, because that's 0 squared minus 4 times 0 plus 3, and that would mean, yes, 3. So if I want to find the displacement between the 2, I subtract them, thank you. I take s of 2 and subtract s of 0, and that is negative 1 minus 3. So it is negative 4, or we say it is 4 places to the left, 4 units to the left. That's the displacement from when it started. It started at 3. That's where it started. It ended up at negative 1. This represents the total displacement, and that means 4 spaces to the left. So, find the average velocity during the first 4 seconds. Xavier, you were right. We're going to take f of b minus f of a all over b minus a. Well, the first 4 seconds. Now, it wants to find its average velocity. It doesn't matter where it's going. It matters the speed with which it is moving. Right? Right? So, question. What do? Shakira, you're right. So, what you do is, you start out the first 4 seconds, right? That's from time 0 to time 4 seconds. So this is your B, and that's your A. And for those of you disgusted by my A, bam, there you go. So I'm going to find out, and of course, with the distance, or displacement, or position, formula, it's an S. So it's S of 4 minus S of 0 all over 4 minus 0. So we know the bottom is the at4. We know what S of 0 is. We just did S of 0. Is it S of 0, 3? But what's S of 4? S of 4 is 4 squared minus 4 times 4? Because this is my t, I'm putting a 4 in here, putting a 4 in there. So this is what?
Where is the equation
That is the original equation. Because how do we find out the average velocity? I figure out where I started, where I went, how long it took me to get there, right? Miles per hour, right? Distance over, how long it takes you to get there. So, what is that? What is 16 minus 16 plus 3? That's 3. Look what happens at the top here. That's just the average. That doesn't mean that's what it's actually going. At some point, it actually stopped and went somewhere else. Because one of the velocity was going 10 miles to the right. And then the velocity stopped and went 10 miles to the left. If I average them, using negatives to represent left and positives to represent right, it's a 0. It's a 0. The average is actually 0. Isn't that weird? Instantaneous velocity, what do we use? Which is?
160 minus 16.
No, we're on this. That's the previous problem. We're on this equation right here. Yes, but guess what? What does that represent? What did I tell you? Why don't we have to use it anymore? It's a derivative. So all I got to do is take the derivative and put it in a 4. Instead of using that f of x plus 8, so all I need to do is find the derivative. Isn't the derivative velocity anyways? So my original equation is what? T squared minus 4t plus 3?
Yeah.
So velocity is just the derivative of position, right? What is that going to end up being? 2t minus 4. And I want to find that at time 4. So all I do now, because the equation that gives us is position. If I take the derivative of that, it's velocity. If I take the derivative of velocity, which is the second derivative of the first one, that's acceleration. Okay. You're right. So v of 4 is just putting a 4 into here. 2 times 4 minus 4 is 4. That's the instantaneous velocity right at time 4. And that is units per second. I don't know, they didn't give us a oh, they did. What is it? It's meters per second.
Oh, man.
Meters per second. Whew, I think I caught that quick, otherwise I would have been 10. All right, find the acceleration at t equals 4. Shakira, we were just talking about this. What does acceleration mean? What do I got to do?
Derivative of velocity.
Yeah, I got to take the derivative of velocity, right? If velocity is 2t minus 4, then acceleration is the derivative of velocity, which is what? 2. And what do we label that? It's meters per second, but it's squared now, because it's acceleration. Question. What would the acceleration be at time 4? Good. What would the acceleration be at time 7?
Always 2.
It's always 2. Yes, exactly. There's no variable here anymore. It doesn't matter what you tell me to put into the variable. It is always 2. Always. For this one, right? The answer is always 2. That came back from algebra 2 a trick. All right. Lastly, at what value of t does the particle change direction? All right. We can see when something changes direction, what has to happen? If something's going one way and it has to change direction, what does it have to do? Yeah, if I'm going to my left and I want to go to the right, that would be pretty remarkable if I could just instantaneously change it. I can do is I have to stop, even if it's just for a second. The laws of physics won't allow it to just change. When I throw this in the air, there's actually a moment of time, ever so very small, that it actually hovers in the air. Not going up or down, then comes back down. It's crazy. So what happens equation I have to use? Position, velocity, or acceleration? Position is movement. It's where it is. Velocity, because I'm moving this way and stopping, my speed has to come to 0 before it becomes negative speed, right? If I want positive speed, it has to come 0 before it becomes negative, doesn't it? So, and there is a way you can do this looking at the graph of the original function. The original function is what? T squared minus 4t plus 3. Velocity is 2t minus 4, right? Set that equal to 0 and solve for t. So what value of t is that 0? 2, because it's 2 times 2 is 4. 4 minus 4 is 0. So t would have to be 2, because 2 times 2 is 4. If I were to take a look at the graph, give me one more second, I know you guys are awesome. If I go like this, right here is the number 2. This is position. This is where position changes from going down to up. But that's also where slope is equal to 0. Horizontal line makes slope equal to 0 right there. Does that make sense?